Something I'm excited about, I'd like to share with you, is if you don't have your own personal graphing calculator, then this might be a useful tool. I came across it accidentally. I was looking for graphing paper, and down here is the graphing paper, but then I saw a graphing calculator. So I clicked on that. And then it says here, graphing calculator, free online tool graph. Now over here, if you want to buy some, there's your Casio and Texas Instruments. Wow, they're really getting up there in price. But these are very modern. We just want to get a little peek at one. So I clicked on that, and this is what it looks like. And they do give you some advertisement because I guess that's how they make their money. But if you just go to the graphing calculator here, this is the screen you get. And here you're going to put in your equations, and you could also do it right there. And then later we're going to graph it. So getting a little bit of a thumbs up on this is I'm going to use my little tool pen. Usually I have this hidden from you. But if you had the equation 3x plus 4y equals 12, let's say. This is in standard form, ax plus by equals c. This is the standard form of the quadratic equation in two variables. And we just write that right in there. Now, in order to write that in there, I'm going to have to erase this, but if you're taking notes on this, this will be useful. So I now get back to my screen here, and I put 3x plus 4y, just from my typing keyboard here. I could also use these little things over there as well, but equals 12. So now I'm going to say to this graphing computer online to graph it. And there's the graph. Wow. Now, in class, we're saying that when you have something in standard form, let's see, it was 3x plus 4y equals 12. When it's in standard form like this, another method that we can use is to make a t-chart. In fact, for most graphs, they want you to make a t-chart. But this is a special t-chart. This is what we call the X and Y intercept t-chart, where under this first row, under the X, you put a 0, and the second row, under the X, you put a 0. Now, we're then going to put zeros into this equation and solve it for the missing letter. So we can change colors here. If x is a 0, 3 times 0 is 0. So this just becomes a 0. And then we have a small equation, short, 4y equals 12. Well, we're going to divide both sides by 4, and we get that y equals 3. Now, if we switch it around and say that y now is going to equal 0. Y equals 0. So this is a 0. 4 times 0 is 0. We're going to divide both sides by 3 now. This becomes an x, and this becomes a 4. So we have established 2 points two ordered pairs, 0, 3, and 4, 0. These are two ordered pairs that we now can plot on our graph. Well, where is 0, 3? Well, it's right there. And where is 4, 0? Well, it's right there. And what have we done? Well, we've gotten 2 points that when we use MATLAB, we could put a dot there, click it, and then drag our line, put another dot there, and it makes this line. And what have we done? Well, here, the line is crossing the y-axis. Remember, this is the y-axis at 3. This is what we call the y-intercept right here, where this line crosses the y-axis. And over here, it's crossing it at x, and x is 4. So we say that when we have x and y intercept t-chart and we find these values when it's in standard form, it's very easy to do. We end up with this one is the y-intercept. And this one is the x-intercept. And what does this mean? It means that the line, which is this graph, will cross the y-axis at this point and the x-axis at this point. And another way of writing this that I may have mentioned in class is 0, b, and this one is a, 0. This is the official way to write the x-intercept. This is the official way to write the y-intercept. And we see it illustrated here. Now, another famous equation is this one, in which we have, let's say, the standard form, but now we solved it for the letter y. Y is all by itself now, and we say a negative 3x plus 2. Now, this is called the slope-intercept form, and the official way of writing it is y equals mx plus b, where this b is the one we spoke of before. This is our y-intercept. This is where this line will cross the y-axis. And m, interestingly, is our slope. So what is in the m position here? Well, negative 3 over 1. So what we're going to do, we're going to go back and put this equation and see what it looks like on our graph. So I have to clear it, unfortunately. Equation, I'm going to delete this one, and I'm going to put y equals, I can type all of these in straight, a negative 3x plus 2. And I'm going to graph. Okay, now notice it's different from the other one because it's a different equation. And let me again write here, y equals negative 3x plus 2, and then analyze this a little bit for you. Remember, this was y equals mx plus b. Now, we had said that b is our y-intercept. So it's going to cross the y-axis at a plus 2. Ooh, look it does right there. And we're saying that our slope is a negative 3 over 1. We have to put the 1 there because we had said that slope is a ratio of y units to x units, or rise over run. Well, what do we have here? Well, we have a negative 3 over 1. So I tell my students that I would graph the x units first. That is my run. And since this expression here is negative, we're going to go over 1 to the left. Now, we're going to go how many units up? That's our rise. Well, 3. Let's do that. 1, 2, 3. Ah, and there's our second point, our y-intercept, and then plotting in our slope. And if it's negative, we go left and then up. Now, notice you could have gone right 1 and then down 3. That would be another way of doing it. And depending on how you had it in high school and other courses, if you're getting the correct slope, you could use either way. Okay? So, 2 ways to graph. Now we're going to take a look at another one, 2 other equations, and I'll plot those on the same axis so we can save a little time. One equation is called y equals b, and another equation is x equals a. Now you recall that b was the y-intercept and a was the x-intercept. But what kind of lines are these? Well, we get to see those by graphing them. So for y equals b, remember b is your y-intercept. Y equals b, I'm putting in y equals 2. Let's graph it. And can you see it's going to be a horizontal line going through your y-intercept right there at 2. Okay, let's go back. And now I'm going to put in x equals 2. Now this is going to be your x-intercept. Let's see what kind of line this is. Let's go to graph, yes. So there was your y equals 2, and now you see your x equals 2 is a vertical line going through 2. Okay. And I have one other that I'd like to show you. We'll clear these. And you'll be doing practice and quiz-bees. But this one is y equals x all by itself. Let's do that one. And then this one too. Y equals x caret. Remember, caret, you could put an exponent on. Y equals x squared. And let's plot these two. Again, I would take notes on this. This would be a good reference for these in general. And you now have this tool that you can do at home. Well, I guess I forgot to put a equal sign there instead of a negative sign. That's better. Let's try that one. So y equals x is this reddish line, and that is linear. That is, it's a straight line. And y equals x squared is a parabola. And that's your typical parabola. Notice the base of the parabola is at the origin. That's your minimum value. And there's lots of other things to be learned about graphing using this tool. But I'll keep it under 16 minutes.